I actually had a lot of fun with the last video. I like doing math. hope this isn't super painful, and hope this video makes things a little bit more clear as well. Let's do example 2. Find an equation of a tangent line, or I should say the tangent line, at the given point. And I really like these tangent line equations because for two reasons. One, they connect concepts, and two, it's very clear whether you're right or wrong just by looking at the graph. Let's do part A. That's saying y equals cosine of 5x squared at x equals 0. So the slope of the function is the slope of the tangent line, which we find with the derivative. The derivative is the slope function. So again, there's kind of two ways that we're going to do this, the red way and the blue way for the derivative. So let's start with the red way, which is the one on the left. We're going to say that y prime is the derivative of the outside function, negative sign, leave the inside function alone, and multiply by the derivative of the inside function. All right? And there it is right there. Or you can use the Leibniz notation and say, what is our inside function? It's 5x squared. What is our outside function? It's the cosine of the inside function. The cosine of u, if u is 5x squared, the cosine of u is indeed this. And Leibniz notation says that dy dx equals the derivative of y with respect to u times the derivative of u with respect to x, just multiplying these two derivatives together. That's going to be negative sine of u times 10x. And again, what is u if not 5x squared? And we usually simplify this one more step. I'll simplify this over here. Negative 10x times the sine of 5x squared. That's usually how we write our derivative. So this tells us the slope of the function y, the slope of the function y anywhere. So the slope is going to be different depending on where we are, and specifically, we're curious about the slope when x is 0. So the slope when x equals 0 is the derivative evaluated at x equals 0. We haven't used this notation for a while. I introduced this like once or twice, but we haven't used it much. This is just a giant vertical bar, and that means evaluated at x equals 0. So that's just going to be 0 times 0. You plug in 0 into the slope function, you're going to get a whole lot of zeros. So the equation of the tangent line is a horizontal line. It's a slope of 0. It's going to be y minus the y coordinate equals the slope times x minus the x coordinate. The x coordinate is 0. All right, we're looking for the tangent line when x is 0. We don't know the y coordinate yet. It didn't give that to us. The y coordinate is what happens when we plug in x equals 0 into our function. And we have two functions here, the original function and the derivative. The derivative is the slope function. The derivative gives us the slope of the original function. We don't need the slope. We already found the slope. So we got the slope from plugging it in into the slope function, and we'll get the y value by plugging it into the original function. So plug that in and use some trig. You should get the y value as 1. So our equation of our tangent line should just be the line y equals 1. Let's verify this with Desmos. All right, so our function is cosine of 5x squared. We're looking for the tangent line when x is equal to 0. Yep, that's the tangent line when x equals 0. In fact, that's the tangent line in a lot of places. All right. There we go. That's this problem. Let's do part B. H of x equals the secant of 4x to the 5th plus 2x. Hope you remember your trig, your 5.5. Was that really just last section? Okay. And again, we'll do it both methods. We need the derivative. It's take the derivative of the outside function and leave the inside function alone. The derivative of secant is secant tangent. But we have to leave the inside function alone. And this is really an example where this method, this shortcut method, is a little hard to follow. We multiply by the derivative of the inside function, which is 20x to the 4th plus 2. I think the blue method's going to make a lot more sense than this one. All right, derivative of secant is secant tangent. Leave the inside of secant and tangent alone. And then multiply by the derivative of that inside function, which is 20x to the 4th plus 2. Make sure to include parentheses. These parentheses are very important. All right. I can't be bothered to type the last 4 letters. Important parenth. Okay. And that's about as simple as it gets. We usually write the polynomial part in the front, but it's not a big deal. Or again, you could go off and use Leibniz notation, which says, okay, well, I'm going to need more room than that. It says, what's our inside function? 4x to the 5th plus 2x. What's our outside function? It's the secant of that inside function. We're just writing function composition a different way with y's and u's. And then dy dx equals dy du, du dx. Dy du just means the derivative of y with respect to u. In future calculus, we talk about partial derivatives. If we took like the derivative of y with respect to q or some other variable, then it would just be 0 because we'd treat u as a constant. But we're taking the derivative of y with respect to u. That just tells us that u is our variable. Just tells us what our variable is down here. So yep, this is the derivative of u with respect to x. X is our variable when we take the derivative of that u. That's what that means. So derivative of y with respect to u is secant tangent times the derivative of u with respect to x is 20x to the 4th plus 2. And again, just like before, the last step is just substituting in u. And you can see that that's going to exactly give you what we had in red. All right. So we need the equation of the tangent line. So we need the function value and the slope. The slope, we plug it into our slope function when x is equal to 0. That's the secant of 0 times the tangent of 0 times, oh gosh, is this just going to be 0 again? I gave us another horizontal tangent line. Plug it into the last thing and you're going to get 2. Yeah, the tangent of 0 is 0. Another slope of 0, that's boring. And the function value, y value or function value, is the function evaluated at 0, which is the secant of 0. That's 1 over cosine of 0. Cosine of 0 is 1. You can either use reference triangles or the unit circle. We look at the unit circle, 0 degrees is here. The x coordinate, cosine represents the x coordinate, and the radius is 1, so this is the point 1 comma 0. The x coordinate at this point is 1. That's why the cosine of 0 equals 1. And then we take the reciprocal of 1, which is also 1. So combine everything, y minus the y coordinate is equal to the slope times x minus the x coordinate. Or again, this is literally the exact same tangent line. It's just y equals 1 again. The secant of, let's graph it, double check. I do make mistakes. Y equals the secant of 4x. What is it? 4x to the 5th plus 2x. Whoa! And this is our tangent line. Yeah, once you get a little further away from the origin, this graph starts oscillating and having a ton of asymptotes. Because if you remember, again, all right, hold on before I go on my rant. Yes, tangent line at 0. Yes, it's correct. Horizontal tangent line. You remember what secant looks like? Just regular secant? All right, it looks like this. It just has a bunch of repeating. They kind of look like parabolas, but they're not. And they have a bunch of asymptotes. Well, we still have secant, but it's secant. And this inside gets really big really fast. It kind of accelerates the function. It's a lot of blue. Oh, gosh. Let's do 2 more problems in this video. All right. Maybe get rid of this. I don't want to look at that. Do part C. Let's move away from trig real quick. H of x equals 2x plus 1 to the 5th times 3x minus 2 to the 7th at the point 1, comma 243. There's no way this has a horizontal tangent line. I'm pretty sure this one's going to be much more interesting. We'll see though. So we've got a little bit of a pickle here, because we have to use the product rule because we have 2 functions multiplied by each other. But when we use the product rule, we're also going to have to use the chain rule. So call this F and this G. We have to use the product rule to say it's going to be F prime G plus FG prime. And we're going to have to go off to the side and find out what F prime and G prime are. It's 2x plus 1 to the 5th. G of x equals 3x minus 2 to the 7th. Jason, you are not going to have room here. You silly guy. I'm giving up. F of x equals 2x plus 1 to the 5th. G of x equals 3x minus 2 to the 7th. And we'll have to take the derivative of each of these, and each of these are going to require us to use the chain rule. At this point, I'm going to go through the chain rule part pretty fast. The derivative of this function is the derivative of the outside function. Leave the inside alone and multiply by the derivative of the inside function. You can also go off and use our methods and do this a little in more steps. Derivative of the outside function, leave the inside alone and multiply by the derivative of the inside function. And now we use the product rule. So to get the h of x is equal to f prime, which is 10 times 2x plus 1 to the 4th, times g, which is 3x minus 2 to the 7th, plus f, which is 2x plus 1 to the 5th, times g prime, which is 21 times 3x minus 2 to the 6th. And now there's a little simplification we can do here. We're going to simplify by combining, by pulling out a greatest common denominator. So let's look at the numbers parts first. What's the greatest common denominator between our numbers? 21 is 7 and 3. 10 is 2 and 5. Okay, there's nothing here. And then we're going to look at what's the greatest common denominator or greatest common factor for this part. Well, it's going to be 2x plus 1 to the 4th is what we can factor out. And then what's the greatest common factor of this part? 3x minus 2 to the 6th. All right, there's 7 of them here. There's 6 of them here. We can pull out 6. And then what are we left with? We're left with 10. We took out all 4 of these, but we only took out 6 of these, so there's 1 left over. And then, oops. that's what we're left over from that first thing. And then what are we left over from the second thing? Again, we still have that 21. We only took out 4 of these, so we still have a 2x plus 1 left over. But we did take out all 6 of these. So we took out a greatest common factor. This was our greatest common factor. And then this is what is left over from each term. This is what's left over from the first term. And this is what's left over from the second term. And now we can simplify that inside and get some nice things. This is 2x plus 1 to the 4th times 3x minus 2 to the 6th times, how do we simplify that inside? We have to distribute. 30x minus 20 plus 42x plus 21. Collect like terms and then try to factor. And then that's where we're going to be. I don't want to write too much below my head, so let's go ahead and move this over here. It's going to be, again, 2x plus 1 to the 4th, 3x minus 2 to the 6th, 30x plus 42x is 72x, minus 20 plus 21 is plus a 1. All right, that doesn't factor. But this right here is our completed first derivative. And now we need the equation of the tangent line. Y minus the y value is equal to the slope times x minus the x value. The x value, I told you, was 1. I also gave you the y value here. I told you the y value is 243. So all that's left is to find the slope. And the slope is just what is the derivative at our x coordinate. So all we have to do is plug in 1 into the above. It's going to be 2 times 1 plus 1, that's 3 to the 4th. Plug in 1 again, that's 1 to the 6th. Plug in 1 again, that's 73. Oh my word, this is a big number. I'm not doing this one in my head. Gosh, wow. I'm a little nervous about this problem. It's a messy problem. There's a lot of places to mess up. 3 to the 4th. This is why we're checking our answer. Times 73. 5913 is our slope. So this is what we think the equation of our tangent line is. Let's grab it and let's see. And if it's wrong, I get to give you guys a good example of troubleshooting. All right, our function is 2x plus 1 to the 5th times 3x minus 2 to the 7th. And we're looking at the point x equals 1. Wait a minute. When x equals 1, oh no, did I do the same thing? Yeah, the y coordinate is 243. Okay, great. We're looking at this point when x is equal to 1. Find the equation of the tangent line. We said it was y minus 243 equals the slope 5913 times x minus 1. Hey, maybe. At least it goes through the right point. Let's zoom in a little bit. Let's look from 0.5 to 1.5. Oh no, that's not it at all. There's a problem with our derivative. I paused the video. I went through every single step to figure out where did I go wrong. I wrote down the wrong function. It's right here. All of our math was correct. I hope you were screaming in your chair. The function is 3x minus 2 to the 7th. Ah, okay. It's kind of hard to see whether this is a tangent line. We're going to need to get bigger values of y. Or zoom in on the x's some more. Let's go from like 0.9 to 1.1 maybe. I mean, even more zoomed in, honestly, to really see. Oh, look at that. Look at that. That's a tangent line right there. That's a tangent line. I was really worried. I was like, I'm teaching calculus. I can't be making these mistakes when I'm doing calculus, you know? Well, no, it's just that kind of mistake. That's why let's do some more. All right, last problem of this video. Example 4. This one's easy. Okay, this is the easiest problem of the video. Find the derivative. We skipped example 3, by the way. That's not even true. We skipped example 2 and I just didn't tell you. And then I forgot to renumber. Find the derivative of h of x equals the cosine of g of x. So we can find it. We don't need an actual function. It's fine if it doesn't tell us the actual function. We can still use the chain rule. Let's do both methods. The derivative is the derivative of the outside function. Derivative of cosine is negative sine. Leave the inside function alone and multiply by the derivative of the inside function. We don't know what g is, so we don't know what g prime is. But we do know the derivative of g would be some g prime. And that's it. Or you could use Leibniz notation and say the inside function, let's call that g. Then y is just the cosine of that inside function. dy du equals dy dx equals dy du times du dx. The derivative of y with respect to u is negative sine of u. The derivative of u with respect to x, again, is just g prime of x. And then what is u? Just replace that u with what it equals, the g of x. And either way, you should get the same answer. And there we go. All right, let me know if you have any questions, and enjoy some of these homework problems. They can be a bit messy.